Okay, in this problem, we are given total daily cost to produce X electronic videos. So if the manufacturer is currently producing 60, how much can the cost be expected to change if production is increased by one component each day to 61? This is a reference to marginal cost, and that's what you're supposed to understand here. So what we want to do is find the derivative of C at 60, and that's actually an estimate for the change in the cost. It's technically or supposed to be a little bit easier than computing C of 61 minus C of 60, which is what probably many of you did. That would give you the exact change in cost based on this formula. So differentiating C for C prime, the coefficient of 1,000 here will just stay out front. Now the derivative of the natural log of a function is 1 over that inside function by the chain rule, so it's 1 over the cubed root of 4x squared minus 600 times the derivative of the cubed root of 4x squared minus 600. Now because I'm going to have to differentiate a cubed root, I'm going to go ahead and write it as a 1/3 exponent. It didn't really matter right here because we're not differentiating that part, but I am going to have to differentiate that. So I'm going to clean this part up here and write it as 1,000 over the cubed root. Now for this derivative by chain rule, we're going to bring the 1/3 down. So it's 1/3 times this is now the inside function, 4x squared minus 600, to the power of 1/3 minus 1 is negative 2/3, times the derivative of this inside function, which let's just go ahead and do it. The derivative of 4x squared is 8x, and of negative 600 is 0. So that's it right there. That's a messy looking derivative. You can simplify if you want, but it doesn't really matter because you're just going to plug in 60 anyways and then see what you get. However, I see something that may simplify quite a bit and may make it a little bit easier to plug in 60. I'm going to go ahead and write that as x. So I'm going to combine all the coefficients. I'm going to use underlining to coordinate here. So we have 8, 1/3, and a 1,000. So let's put that first. So 8 and the 1,000 multiplied together are 8,000 over that 3. So just to coordinate, those are those same numbers there. Now here's what I'm noticing is that we have a cubed root in the denominator and a power of negative 2/3. So I'm going to put this negative 2/3 in the denominator and write it as a cubed root. Actually, no, I take it back. I'm going to write this one as an exponent because then I'll be able to add the exponents and it will simplify a whole lot. So I'm writing this radical, let's do green, with a fractional exponent, it would become 4x squared minus 60 to the 1/3. Now this negative 2/3 exponent, if I write that in the denominator and make that exponent positive, it becomes 4x squared minus 600 to the positive 2/3. So what I noticed, and this is just from experience really, is that I could see that when I write these all like this, when you add these exponents, because you have the same base, 4x squared minus 60, 4x squared minus, that's supposed to be a, oops, they're all supposed to be 600. There's a typo there, 600. Anyways, they have the same base, 600. So you add these two exponents, coordinate there, hang on, brown and brown. Okay, now we're going to add the 1/3 and 2/3, and it becomes just 1. So then you don't have to worry about entering any radicals or fractional exponents actually in your calculator at all. They completely go away, which is really nice. So 8,000 over 3 times 4x squared minus 600 to the first power. So I'm just going to leave it like that, and it will be much simpler now to plug in 60. And I left off this x here, I just noticed. That x should be up here, x and x like that.